I will show you a theoretical presentation on how do we use a Spark pool for all such operations.
Mm-hmm.
So whatever we have covered in the last 6 classes will be covered today, but execution engine, basically the operating system where you run your queries, will be Apache Spark. And here
Okay.
there are two options. Do the same operation, do the second exercise. You are doing using SQL now. You are writing create table commands and then doing a select star, right? On
Mm-hmm.
a SQL pool. So where you go to your query and there is a attached to column on the top. So in that drop down, you would see a SQL pool or a built-in, a keyword.
Mm-hmm.
So that is running the queries on the SQL engine. But today we will see how to run a Apache Spark, platform, and under which you can you can use two languages. One is Python by Spark, and the second is SQL again.
Mm-hmm.
So that platform is a bit flexible. Based on what you pass the notation at the beginning of the script, I'll show you what that notation is. You can choose your language and then choose to run it. But eventually,
Okay.
it is the same operation. Okay, Apache Spark. Why do we need it? Because you are already practicing it on a SQL platform, right?
Mm-hmm.
So, what is the purpose or what is the need to have another alternative way to run your query? If you talk about the volume of data, so Apache Spark is capable of handling a larger volume, larger chunk of data, and then
Okay.
process it on the fly. So this is mostly used to have an improved performance on your data set.
Mm-hmm.
So when your SQL query lags to execute a certain data, you can choose Spark to have it done in a quicker manner. So
Mm-hmm.
what happens? Why is Apache Spark faster than the SQL engine? Whenever you opt for a SQL engine on the backend, it is consider it as a single OS, a single
Okay.
CPU system. Single CPU may have a higher configuration. You could
Mm-hmm.
use a 8-core CPU engine and then a very good memory on the backend, but it is still a single OS.
Mm-hmm.
But when it comes to Apache Spark, it is a parallel processing systems. So whenever you give a task to process 1 GB of data to SQL, it is considered as one job.
Mm-hmm.
But if you give the same work to Apache Spark, there is a map and reduce, similar to how the big data works. One
Okay.
main task, it will be divided into multiple chunks, and each chunk will be given to a executor node. So when I say
Okay.
executor node, it is similar to a mini OS within which that particular task gets executed, and all the result set is combined together in another node which is solely built for the merging purpose.
Mm-hmm.
So if your one task on SQL, it is divided into 10 or n number of tasks which is passed to sub nodes where for the execution. When the execution is done, the result is gathered and that result is merged together and presented to the user.
Okay.
So that is the main purpose of having a Apache Spark engine.
Mm-hmm.
So process large data and process faster. So what does this platform give you? I mean, it includes a lot of other services. So when we talk about HD inside Databricks, Synapse Analytics, we have already used. So these two are the additional platform you can run with. So in
Mm-hmm.
the core of those tools, it is still an ETL engine, extract,
Okay.
transform, load. But how you choose the platform depends on what kind and what amount of data you are processing.
Mm-hmm.
And then we are already aware of Synapse Analytics. That is fine. Okay. So the internal architecture of Apache Spark. We will have a driver program. This means that whenever we create an Apache Spark engine, we have created a Synapse Studio, right? Synapse
Mhm.
Analytic Platform, uh, within which you have a SQL engine, a built-in SQL spool, or you created a retail DB in your current exercise. So that is
Mhm.
a dedicated DB created within the Synapse Studio. And
Mhm.
similarly, you create Apache Spark. When you create that, there will be something called as a driver program. So what it does is it creates multiple clusters of
Mhm.
for you to execute. So the scaling of these clusters is again automatic. So whenever you execute a query on Spark platform, so it creates some sort of an execution plan. So it
Mhm.
estimates how much computing power you need to complete that query execution. Based on that, it replicates the executor nodes.
Mhm.
So if 4 is enough, it will just execute with 4. If you need 50, then you will have 50 executor nodes. And all your job is divided into equal chunks and passed to those 50 executors. And all those executors will work in isolation, and each isolated block will interact with the same source. For example,
Okay.
if you are choosing a file for processing with a million records, and if you have five executor nodes, and each node can take a 200,000 records, so it is referring to the same location. First executor will take the first 200, second will take the second 200, and so on till the
Mhm.
last executor node. When the result is done, the cluster manager again uh, is responsible for clubbing all the result together and present it to the driver program.